Dear participants of the conference, dear colleagues, my name is Zupanec, and I'm Associate Professor in the field of teaching methods of biology and ecology on Faculty of Sciences at University of Novi Sad in Republic of Serbia. It is my pleasure to, on behalf of the team of professors and researchers from the Faculty of Sciences, University of Novi Sad, present the most important results of the work entitled The Effect of the Flipped Classroom Model on Quality of the Students' Performance in Biology Education in High School. We conducted this research at a time of widespread use of information and communication technologies in education, as well as the high availability of technological devices to teachers and students at school and at home in order to examine the effectiveness of flipped classroom model, FC, and traditional classroom model, TC, in biology and quality of high school student performance. We are witnessing the daily emergence of new learning concepts and teaching approaches in order to improve the learning process. One of the innovative teaching models that has aroused the interest of educators, numerous didactics around the world, is the flipped classroom model. Flipped classroom is a pedagogical model that obliges students to access various digital teaching content, videos, multimedia presentations, etc., before class, which introduces them to the content that will be depend in class, and that deepening of knowledge in class is done through practical activity students, solving specific problems, applying acquired knowledge in new and different situations, as well as productive and creative discussion. This teaching approach puts the student in the center of attention. Thus, in a FC or flipped classroom, the focus shifts from the teaching process to active student participation and learning, creating conditions for better interaction among students themselves, as well as between students and teachers, and developing students' functional digital competencies. The number of research studies examining the impact of flipped classroom on students' performance in biology education has increased in recent years. These researchers came to the conclusion that the flipped classroom provides more time for one-to-one between the teacher and students. Students have more group work or student collaboration time to cover subject activities, discussions, and peer reviewing. Students' learning can be self-paced to help them learn at their own pace and in their own time. Students are more engaged with flipped classrooms or lectures as they are researching, completing activities, or discussing the subject. With traditional teaching, the teacher would generally be providing all of the information to them. As students are researching and discussing themselves, the students gain a deeper understanding of the subject and related subjects. Although all these researchers points out the FC as a good alternative to the traditional classroom. There are also those studies that showed that traditional teaching was more efficient in terms of student performance compared to FC. Considering that in the last few years in the Republic of Serbia, thanks to the enthusiasm of a number of biology teachers, educational material in the form of short YouTube videos for application of FC has been prepared and made publicly available. One of the key conditions for its application in biology teaching has been provided in both primary and secondary school. This created opportunities for greater implementation of this model of work in the teaching of biology, but also to test the effectiveness of this model in the implementation of biology programs in teaching practice. Therefore, the aim of this paper was to examine the effects of FC model on the quality of students' knowledge at 3 different cognitive levels: remembering, understanding, and applying, according to the revised Bloom's taxonomy in biology teaching at high school compared to traditional teaching. Observed through teaching practice, the FC model includes 2 groups of activities: pre-class and in-class learning activities. Within the pre-class activities, the teacher first selects teaching units suitable for processing using the FC model. He or she then prepares the necessary teaching material in the form of educational video lessons, in which the material is presented in a concise form and distributes it to the students. After that, students have homework to solve, and it is related to the reviewed educational material in order to gain an understanding of the basic biological concepts that will be covered in more detail in class. As part of preparing students for the class, students can make a brief concept of the reviewed material, extract key information, write down ambiguities and difficulties encountered during reviewing the material, write down a few questions that were not answered in the material and want to know the answers. In the phase of preparation for the class, students should be given freedom of expression in accordance with their abilities and interests, which to some extent achieves individualization in teaching and learning. The video also allows for individualization, namely each student can stop on rewind a certain part of the recording faster to study the material at home, outside the classroom, and the time frame of the class at the time that suits him best. With this preparation of students for the class, much more time remains in the classroom for conducting in-class activities. In-class activities include more meaningful and creative student activities related to problem solving and the practical application of knowledge in a group form of work that contributes to deepening knowledge and understanding the sense of the studied material. The role of the teacher in the class is to help the students, not to give information in a ready-made form. This organization of class activities allows the teacher to devote more time and attention to students who learn more slowly. In this way, the role of the teacher has changed. He becomes someone who has time to deal with each student separately and can be a leader, organizer, and mentor. The teacher guides the students in conversation, gives feedback and advice. Such procedures in class complement the individualization of teaching and learning, which is one of the most important advantages of this model of teaching compared to traditional teaching. Although the value of the flipped classroom is emphasized in a large number of literature sources, there is still an insufficient number of published empirical research papers examining the impact of FC on improving teaching, learning, and student achievement, especially on the quality of students' knowledge. The results of this study will provide evidence of prevailing situation and provide biology teachers with useful suggestions for the appropriate application of FC in teaching practice. According to the aim of the study, the pedagogical experiment was conducted with parallel groups. Students from the experimental group E studied the contents of the cell structure and function within the biology classes for the first grade of high school by using the FC model, while at the same time, the students of the control group or C group learned the same contents by using the TC or traditional classroom model. The two groups were evaluated to identify differences in students' cognitive performance by levels of knowledge, remembering, understanding, and applying, according to Bloom's revised taxonomy. A sample of convenience consisted of 280 students from 1 high school in Novi Sad, Serbia, who participated in the research. In total, every group, E and C, consisted of 40 students. The respondents were the first grade student of high school, aged from 14 to 15. Experimental research was carried out in the school year 2018 and 2019 during regular biology classes which dealt with content related to the cell structure and its functions. The work with students from both groups encompassed a total of 12 regular class periods, each lasting 45 minutes. At the beginning of the research, both the groups of pupils were tested with a pretest in order to synchronize the previous knowledge of students in both groups. After pretesting, the students in the experimental group learned biology topic through the FC model, whereas the students in the control group were taught the same topic by the traditional classroom model. Upon completion of the analysis of the teaching topic cell structure and function, students from both groups took the posttest at the same time. The posttest contained questions arranged according to levels of complexity according to the Bloom's taxonomy in order to examine the quality of students' knowledge of biology program content, which was processed in the experimental part of the research using FC models and DC models. We came to the following results using the described research methodology. The results of students' performance obtained on the pretest, which are shown in table 1, show that students of both groups achieved the greatest success at the first level of knowledge or level remembering. Weaker success of both groups was achieved at the second level of knowledge, level understanding. The students of both groups achieved the weakest success at the third level of knowledge related to the level of application. By applying the Mann-Whitney test for the 2 independent samples, it was concluded that there is no significant difference in the number of points achieved between students in groups E and C at individual levels of knowledge and the test as whole. This proved that the E and C groups before the introduction of the experimental factor were homogeneous according to the quality of knowledge achieved in the pretest. At the end of the experimental research, both groups of students solved the posttest and its results are shown in table 3. The analyzed results obtained on the posttest showed that students of both groups achieved the greatest success at first level of knowledge. Weaker success of both groups was achieved at the second level of knowledge, and the weakest success of both groups was achieved at the third level of knowledge. The results achieved on the posttest as a whole and by cognitive levels show differences in favor E group of students. Based on the results of the Mann-Whitney test for 2 independent samples and the obtained p-values shown in table 4, can be concluded that there is a statistically significant difference in the performance of students of E and C groups at individual cognitive levels and at the posttest as a whole. Also, the obtained results indicated that the biggest difference in the performance of students of E and C groups was achieved at the second level and then at the third level of knowledge in favor of the E group of students. This indicates the positive impact of flipped classroom on the quality of students' knowledge, especially in solving tasks that require understanding and application of knowledge in biology in relation to the impact of traditional teaching. In order to examine the progress students in groups A and E, experimental groups and control groups during the experimental research, a comparative analysis with Wilcoxon-signed rank test has been used for the results achieved on knowledge test for each group of students individually. The results of this test are shown in table 5. The results of the statistical analysis indicate that the students of group A or the experimental group on the post-test significantly improved compared to the pre-test. Progress of experimental group can be attributed to their learning, which was individualized and independent. They invested additional effort in independent preparation for the class by reviewing the appropriate video created for the processing of certain teaching content, so that the time in class was not used for frontal lectures by teachers, more for deeper analysis of content, essential understanding of the subject matter through interactive activities with other students and the teacher. The teacher discreetly led the lesson from the background, leaving the students to be maximally active. Such actions of teachers, creative behavior of students during the processing of the teaching topic, the cell structure and function, participation and initiative of students in given school activities, interpersonal relationships in classes, interested students in group E for work and personal progress. Integration of all mentioned elements of the flipped classroom improved the teaching of biology and provided students with functional knowledge. Unlike the students of group E, the achievements of the students of C or control group on the pre-test and post-test were very similar. Such results are most likely a consequence of the unchanged traditional way of working. During the processing of the biology contents, the students of Group C listened frontal lectures of the teachers, participated to the same extent in the discussion about the studied contents, but not enough to achieve a better learning outcome. Their insufficient involvement in the teaching processes and the lack of initiative to initiate a discussion regarding the studied content led to the realization of significantly lower achievements on the post-test compared to the students of Group E. The findings obtained in this study are consistent with the results of their researchers who have applied the FC model in teaching biology as well as other subject areas, teaching chemistry, math, science, and social studies in computer interaction course. Based on the analysis of the conducted research and the obtained results, the following conclusions can be drawn. The applications of the FC model in biology teaching has a positive effect on the quality of students' knowledge and their practical applicability, because the study showed that this innovative teaching approach has a significant impact on the development of competencies, especially for problem solving and critical thinking, as well as the acquisition of functional knowledge, as evidenced by the fact that there is a statistically significant difference in the achievement of students E and C groups. Achieved on issues of second and third cognitive levels, which require remembering and applying knowledge. Based on the results of this study, the flipped classroom should take an appropriate place in the teaching of biology in high school. The results of this research can be an incentive to conduct future similar research, but on larger sample, in order to obtain more reliable results in the study of this innovative model of work. Another limitation of this study that should be removed in future research is the length of experimental research. Also, this paper lacks the effects of FC on knowledge retention. So this effect should be investigated in future research. Considering the positive influences of a flipped classroom on the quality of biology teaching in high school, in spite of some limitations, this study suggests several implications for educators. In order for the flipped classroom to be properly implemented in the teaching process, it is necessary for the teacher to follow modern trends in didactic research to improve his professional and didactic knowledge, as well as to develop information technology skills to apply them in his teaching practice. Thank you for your attention.